Hello guys, this is Jitendra and this is our 7th signal and system lecture. In last class we have discussed about LTI system and basic of convolution. We have already discussed few properties of convolution also. I will cover it in this lecture also, and few were left, we will cover it in this lecture. So first property of convolution is x of t convolution with del of t minus m equal to x of t minus m. It is important property. If we convolve any signal with impulse, shifted impulse signal, the whatever term is here, t minus m, will be replaced here. So we get x of t minus m. This is important property. Second property is if x of t convolution with h of t equal to y of t, then x of t differentiated m times convolution with h of t differentiated n times we will get y of t differentiated m plus n times. Which means m and n are order of differentiation here. Okay. And third property is x of alpha t convolution with h of alpha t equal to 1 by mod alpha y of alpha t. When where y of t equal to x of t convolution with h of t, then if you scale all three signal, means if you scale these two signal, you will get out and convolve it, we will get output 1 by mod alpha y of alpha t. Fourth property is convolution of any two causal signal, you will get a causal signal. Okay, you can take example like two causal signal, like one is step signal, second is ut to power minus at. You can take, you will get causal signal. Similarly, convolution of two anti-causal signal, you will get an anti-causal signal. Okay, so sixth important property is x of t if y of t equal to x of t convolution with h of t, then area under y of t will be equal to multiplication of area under x of t and area under h of t. Means area under y will be equal to area under x into area under h. Okay, this is important. Next property, which was not covered in previous lecture, is x of t minus m convolution with h of t minus m. You will get output y of t minus m minus n. Okay, you will get output shifted by amount m plus n times right side. Okay, because it is minus, so right side shift will be there. So okay, this is important. Next property is, okay, u of t convolution with u of t, will get r of t. Actually this is not property, I written here in property this because if you go to solve the problem, if you remember this, you don't need to calculate, you don't need to use this that formula of convolution, like integration minus infinite to plus infinite x of tau h of t minus tau t. You don't need to calculate this all, just you need to remember this. Okay, this will be, then you will take less time to solve any problem. Okay, because in gate purpose, if you see from gate point of view, then this will be very helpful. This all property you don't need to remember actually, but if you remember, it will be beneficial. Okay, otherwise you go through the formula, you will get same result, but if you use this property, you will require less time to solve the same problem. Okay, so convolution between two step signal you will get a ramp signal. Okay, this property will be proved by next property, which is if you convolve same signal, means f of t convolution with f of t, you will get output integration of that signal. Okay, integration 0 to t f of tau d tau. Okay, this is useful. If you put f of t as u of t, you will get, as we know, integration of step signal is ramp signal. Yeah. So next question is u of t we have to find u of t plus 1 minus u of t minus 3 convolution with u of t plus 1 minus u of t minus 1. Here we have to find this convolution. Okay, so what we have to do, we have to open this bracket and expand it, so you will get like this. Then as we know that convolution between u of t and u of t, you will get r of t, means ramp signal. Okay, but here what is difference? Here only difference is shift. There is shift between there is shift in u of t. So one property will be useful. Seventh property, x of t minus m convolve with h of t minus n, you will get y of t minus m minus n. So here m is minus 1, n is minus 1. Okay, if there is minus, there will be minus. If there is minus, there will be minus. There is plus, and there is plus, there is plus. So you will get here plus 1 plus 2. Okay, here plus 1 minus 1, you will get 0. So r of t minus 0, r of t. Here minus 3 plus 1 minus 2, and here minus 3 minus 1 minus 4. Okay, you can draw it. Actually this signal was a rectangular signal from minus 1 to 3, and this signal was rectangular signal minus 1 to 1. The output is a trapezoidal signal. Okay, so what we conclude from this result, that convolution of two unequal length rectangular pulse. This two unequal length, its length is 4. Length means duration of the signal. Its length is 2. So two unequal length rectangular signal. Convolution between two unequal length rectangular signal will always give you a trapezoidal shape signal. Okay, always remember. So lower limit, I discussed in last lecture. Convolution output, lower limit will be sum of lower limits of input signal, and upper limit will be sum of upper limits of input signals. Okay, so and if input signals are rectangular pulse with unequal length, then the output will be trapezoidal pulse, trapezoidal shape signal. If the two signals are rectangular signal with same length, then the output will be triangular signal. Convolution of two equal length rectangular pulse will always give you a triangular signal. Okay, so next question is, we have to find y of t equal to x of t convolution h of t, and x of t and h of t is given. This is h of t. It is actually periodic impulse train which we have drawn here, and x of t is given in question. So if you convolve these two signals, so x of t convolution with h of t equal to, instead of h of t you can write this. Okay, sum of impulse signals. Now you can put x of t inside the summation, because t is independent of k. You can write it. Now as we know, one property was, if you convolve these two signals, I already, first property was whatever term is here in impulse function will be replaced here. Okay, so you will get x of, instead of t you have to write t minus 4k. Now you can expand the summation. Now you can draw it. Okay, so what we conclude from this result, thus convolution of any signal with periodic impulse train will give you periodic repetition of that same signal. Okay, I written here, convolution of a signal with a periodic impulse train is periodic repetition of that signal with same period of impulse train. Okay, so convolution of any signal with periodic impulse train will give you periodic repetition of that same signal with the same period of impulse train. Okay, and if you want to get back the original signal, original input signal, which was that signal, then one necessary condition is channel width should be greater or equal to signal width. Otherwise, because here channel width was 4, here channel width was sorry, I am mistaken here. This is t minus 4 k na. That's why here 0, then here will be 4, then here will be okay. Actually I have written here k's value, but we should write here t's value. So the one mistake has been done by me, that here should be 0, 4, 8 like this. So channel width is 4, okay, and the signal width is 2. So channel width should always be greater than the signal width, okay. So next topic is eigen function. We'll discuss more about convolution. First of all, you see eigen function. What is eigen function? Input to a system is eigen function if output has same form as of input. If we apply an input to any system, and if we got output same form as input, then that input will be eigen function, okay. So second point is output due to an eigen function equal to eigen function into eigenvalue, okay. Eigen function what we have applied at input, and what is eigenvalue? Eigenvalue is a transfer function at input frequency, okay. Impulse response Fourier transform is transfer function. If we calculate transfer function at input frequency, we will get eigenvalue, okay. We will discuss in problems also. Next point is every input signal is an eigen signal to the system described by h of t equal to a into del of t. A system whose impulse response like this, a into del of t, then every input signal will be eigen signal, okay. Why? Because output will be equal to x of t convolution with h of t. Instead of h of t, you have to write a into del of t. Now you convolve x with a into del of t. What you will get? X of t convolved with del of t. We know that we will get x of t, okay. First property, you remember only change will be in amplitude, okay. Eigen function will, I told you that due to eigen function the output will be same form of the input, but only change may be occur in amplitude and phase. Here amplitude changed. So complex sinusoid and complex exponential are always eigen function. Complex sinusoid like e to the power j omega naught t, complex exponential like cos omega naught t, sin omega naught t, like this. Sorry, complex exponential means like e to the power st, like this. And next question is y of n is equal to summation k equal to minus infinite to plus infinite x of k g of n minus 2k, where g of n is given u of n minus g of n minus 4 and x of n is given del of n minus 2. So we have to find y of n. First of all, put x of k as del of n minus 2. X of k, you have to write del of k minus 2. Here you write it. Then now you multiply this two signal. What you will get? As we know that this impulse sequence will be non-zero only at k equal to 2. So this multiplication of two signals will be non-zero only at k equal to 2. So the one property was that this value leads to give you g of n. You have to put k equal to 2, okay. So you will get g of n minus 4 into, actually there will be into summation del of k minus 2 will be 1. As we know, area under impulse function is 1, so we will get 1 here. So gn minus 4 we get. The reason is here what I have told, same reason. And g of n minus 4, you have to put n minus 4 instead of this n, you will get, okay. Next topic is again based on convolution. In discrete case there are two types of convolution, okay. So first is linear or ordinary convolution, second is circular or periodic convolution, okay. It is easy, you don't need to worry about this. So first is linear convolution or ordinary convolution. So question is find linear correlation between x of n and h of n. Sequence is given, x of n sequence and h of n sequence is given. In x of n, what this arrow indicates? This arrow indicates where is the n equal to 0. This sample is 2 at n is equal to 0. This arrow indicates at n is equal to 0, sample value is 2. Here there is no arrow, means by default arrow is here. If there is no arrow, means sequence start from n equal to 0. Okay. So x of n range, this is 0, means this will be -1, and this will be 1, and this will be 2. Okay, and here 0, 1, 2, 3. So first method is sliding strip method. So you can find limits of yn. Okay, here as I discussed earlier, sum of lower limits and sum of upper limits will be respectively lower limit and upper limit of the y of n. Now what you have to do, first method is sliding strip method, second method is column addition method. So I will go for first sliding strip method. What you have to do, you have to write x of n here, first of all you have to draw two lines, then you have to write x of n here, h of n here, then you have to multiply 1 into 1, 1, 1 into 2, 2, 1 into 3, like this. Similarly 2 into 1, 2, 2 into 2, 4, like this. Similarly you have to multiply all this, then you will get like this. Then you have to draw this diagonal lines. Okay, now you have to, so first sample value will be of yn will be 1, second will be addition of this 2 to 4, third will be 1 plus 4 plus 3, like this. This will be like 4, 5, 6, 7 sample. Okay, and direct we can know that y of n will contain m plus n minus 1 number of samples, where m is the number of samples in x of n and n is the number of samples in h of n. Second method is sum by column method. That was sliding strip method. Second method is sum by column method. So you have to write x of n, h of n, then you have to, what you have to do, you have to multiply x of n with first value of h of n, means 1 into 1 you write 1, 2 into 1 you write 2, 3 into 1, like this. Then you have to multiply x of n with second value of h of n, 2, means 1 into 2, 2, with shift of one amount. Okay, you have to slide by one amount. 1 into 2, 2, 2 into 2, 4, 3 into 2, 6, 4 into 2, 8. Now again you have to shift 1, and then you have to multiply x of n with third value, then again you have to shift and you have to multiply with fourth value. Then you have to add, means first of all you write first sample is 1, second is 2 to 4, third is 3, 4, 1, add, you have to add these 3, like this. You will get y of n. And if you have x of n and y of n, you have to find h of n. Then what you will do, again any one of these two methods you can apply, you will get. Okay, first of all you know that y of n contains some samples m plus n minus 1. So number of samples of y of n you know, and number of samples of means m in x of n you know. You have to find n. You will find n. Then you assume it that suppose a, b, c, d are samples of h of n. You apply this, any of these two methods. I recommend you to apply this sliding strip method. You can apply this also, no much deal with it, but I think it is simple sliding strip method. Okay, so circular convolution we will discuss. So we have discussed the linear convolution. Circular convolution we will discuss in next class. Okay, And if you like my lecture, please subscribe for next lecture. And if you have any suggestion related to my lecture, or if you have any doubt, please write into the comment box. Thank you.